I'm Nolan Mackey from Standard Fluids. I'm the project manager at Standard Fluids, the less experienced one of our team, and I'm happy and excited to talk today with Paul Rivers, our principal senior advisor on the technical side for Standard Fluids, and Steve Pignato, who is our global sales manager and operations manager for our engineered fluids market. And I'm really excited to talk to both of you guys today more about the history of the products that we offer, how we kind of maybe got here today and everything. I've only been involved in this market or this industry for a year or so now, since we started Standard Fluids last year, and still eager to learn a lot more and maybe build on some of the questions that we've gotten from some of our customers over the past year. And so, I'd like both of you guys can start. We'll start with Paul. Paul, you can go first and kind of do a brief overview of your career. Then Steve, maybe hear some more from you.
Well, thanks, Nolan. I appreciate that. I've been in the fire protection market for about a half a century, actually. It's been quite a while, and I was hopefully I was going to be retiring, but when Standard Fluids opportunity came along, I ended up getting dragged back into the market, and but I started out in fire protection. I actually have a long history in my family in fire, and I went to IIT in Chicago. One of the last of the people that went to IIT. There's still some that are around, but that was at IIT in Chicago, and worked there. Went to school there, was in insurance and consulting a little bit, and for over a decade in contracting, fire sprinkler contracting, and then for about 30 years in 3M. So, and it was with the experience at 3M that is lending the credence to what we're doing here at Standard Fluids today.
And good morning, I'm Steve Pignato. Started working in this area when I was around 20 years old. I started in the laboratory at 3M. I worked in the fluids laboratory with Paul, and my father at the time, he was there as well, and really started working with these fluids that Standard Fluids is providing and developing applications around the engineered fluids and around the C6 ketone that Paul worked with in fire protection. It's also used for immersion cooling in data centers. And then spent 4.5 years in the laboratory doing engineering work. I'm getting my chemical engineering degree from the University of Minnesota. And after I got my degree, I decided I didn't want to be in the lab anymore. So I went into sales at 3M and really worked in developing the markets in semiconductor, data center, pharmaceutical, electronics, healthcare. So many different applications and industries that we serve with these fluids, and very happy that Standard Fluids was able to start up and kind of take the ball after 3M fumbled. So here I am.
Yeah, one of the interesting things about Steve is he mentioned his dad, John Pignato, and John actually is the one that hired me into the laboratory, and he was I learned how to be very effective in the laboratory working with John. So that was quite. And if you want to know what John Pignato looked like, just look at Steve. He's a chip off the old block.
So. Yes, very handsome, right?
Yeah. Yes.
All right.
Yeah. So that's kind of a good segue. Like, Steve, you were kind of getting put into this market or into these positions from a young age because your dad was doing this, right? So you kind of had experience in the lab before you were even in the lab, right?
Right. So really, the products, the evolution, the product of these fluids and whatnot, I did as a kid, grew up with my dad at 3M working in fire protection. So I had seen what the fluorochemicals were from 3M and met many people that my dad worked with when I was a kid. So when I started at 3M, I was actually a janitor when I was 19. I was at the University of Minnesota, and my dad said, hey, call my old friend that, I worked with as a janitor when he was a kid. And I got a job as a janitor at 19. And then when I had my first quarter of chemical engineering, I was able to get into the lab as a tech aide, and really, like, as far as these products were concerned, 3M for decades was selling perfluorocarbons, which they are great chemicals, but they have very high global warming potential. And really, in the 90s, when I was in the laboratory, 3M was dedicated to creating chemistry that was more sustainable. And that was really the birth of the Novec fluids and the hydrofluoroethers and the perfluoroketones that Paul worked with in fire protection. But that need for 3M to reinvent itself after decades of making perfluorochemistry, there's a gentleman by the name of Rick Flynn, who was the chemist who had invented the HFE molecules at 3M. So, and as a tech aide, I was able to work with those chemicals and measured, the typical properties and some of the breakdown information. So I got to work with these right from the start. And what really kind of developed into sustainable chemistry that ultimately, with 3M exiting the business, I say this all the time, but 3M threw the baby out with the bathwater. So some of the issues that 3M had in the past really caught up with them, and them getting out of that business was a very disastrous thing for many industries and for us personally. But Standard Fluids was able to come out of the ashes basically and start this new business and support the chemistry that was developed in the 90s by all these chemists and engineers and scientists, and really proud to be part of that, and then to have all the experience over the past 30 years. I didn't mention that I've been at 3M since 1990, I guess. So it's been a long time, and it really shaped me in the fact that I was able to see all of the different applications and all of the abilities that these chemistries had. So
Yeah.
That's a real good point too, because in the 1990s, you mentioned rising from the ashes. I refer to it as the phoenix rising from the ashes, and that's basically what happened. And all that experience that we had to transform our business back then from these materials that would today be very much considered unsustainable to new technologies. You mentioned the hydrofluoroethers, the fluorinated ketones, and many other materials that have a zero ozone depletion potential, very low global warming potential, and they're materials that would partition to the atmosphere as opposed to the problem materials that partition to the groundwater and are persistent as a result of that. And what the team at Standard Fluids now cut their teeth on that development, that product development, and that experience is lending credence to what we're doing today with Standard Fluids.
Yeah, no, it's been very interesting to kind of learn how, like Steve said, throwing the baby out with the bathwater. These products were really kind of coming into their prime right at this point of 3M kind of shutting down. And I'd love to hear both of your guys' perspectives of the products that preceded these fluorinated products, and what it was about those. Maybe like going into a little bit of the chemistry, because I know Steve sometimes Steve goes mad chemist and we'll start talking about molecules and tails and chains and all that stuff.
Right.
And so I'd love to know a little bit more about what preceded those, and then ultimately why these ones were developed to solve some of those problems.
Right. Well, really, there wasn't any precedence in this area, really. So the very, very beginning of perfluorochemistry, it really happened in the 30s, and you have to really dig into the history quite a bit, but it's out there. And a gentleman by the name of Joseph Simon, he was a professor at the University of Pennsylvania, Penn State University, and he developed electrochemical fluorination, which is a process with electricity hydrocarbon, and HF, three of the nastiest things you ever want to work with, and create the most inert substance, which is perfluorocarbon, which is, these are liquid Teflons, basically very, very inert. Yeah. And that product was developed in the 30s for the Manhattan Project. So they needed, and the details of this are beyond me because it's all national laboratory type stuff, but I'm assuming that they used the perfluorochemistry. They used it in uranium hexafluoride separation, and they didn't want to use water because water would get very nasty with the uranium hexafluoride. So the PFCs, the perfluorocarbons being so inert, they worked very well. So they really didn't replace anything in the beginning. They really just fit a need. And all the way through the 40s, 50s, 60s, 70s, it was found out that these fluids could be used to cool transformers. They could be used to cool radar arrays, electronics. And then it was developed into electronic testing for military type electronics that needed to be hermetically sealed or very robust. So that really was the start of this perfluorocarbon liquid business, right? DuPont, of course, they created Teflon, and that's more of the solids and elastomer business. But on the liquid side, what 3M was doing with electrochemical fluorination really honestly didn't replace anything. It just created its own market for decades.
It was something new. Yeah.
Correct.
My experience when I first started in the laboratory, right about the same time that Steve started, when he was still doing the janitor work and going for his BS in chemical engineering. I started in the laboratory working with Steve's dad, and the first thing that I was working with the U.S. Air Force. And we're using one of those perfluorocarbons, is the C6F14. A perfluorohexane is the material. Again, very, very stable, very inert, easy to work with, safe, all those things. We did testing with the Air Force and with the Navy, and they accepted the material as a replacement for Halon 1211. It was a material that was being controlled eventually on a phase out schedule per the Montreal Protocol. And so we did the testing, passed all the tests, everything looked great. They just said, it looks great, but we can't test with it, according to the US EPA, because if you emit it, it's considered a greenhouse gas. It turns out it had an atmospheric lifetime of 3,000 years and a global warming potential of 8,000. Not a real good thing, especially for today's market. Yeah. So they said, we love it. It works great, safe, puts together. Go and invent something looks just like that, but doesn't have all the environmental issues with it. And that's what we did. And we invented the C6 fluoroketone, which is a C6F12 instead of the C6F14, but then you had a carbonyl group in there and an oxygen. And that's made all the difference in the world environmentally. But it still made it as safe. We could manufacture it effectively, and it was environmentally benign in that respect. So that's what we did, and we ran the test again, and now the Air Force and the Navy has specified it for key applications, and we continue to do that today. We've redeveloped with our SF1230 fire protection fluid. And then Steve's working with the molecule to do some other engineered fluid applications.
Yeah, and if you don't mind, I'll take the ball from there because I'm looking at some of the questions, and it's what are the challenges that we encountered for developing these molecules, which are
I was gonna say Paul kind of made it seem so simple. He added a few molecules and it suddenly made it so much better. But I know there's a lot more to that.
I only play a chemical engineer on television.
Yes.
Steve is a real one.
Yeah, let's hear from Steve.
But what I'm thinking though is you look at the safety of the molecule in fire protection and how it was developed and why it was developed in one of the biggest applications that we have at Standard Fluids is this data center immersion cooling, where it was really, started in like 1968 by IBM, and IBM used it through the 70s, and Cray Research used it through the 80s and 90s. And then it sort of fell off when new technologies came around. So the future in two-phase immersion cooling really started after 2010, 2012, where we started to use some of the Novec fluids for cooling. And due to some of the properties of the HFE, or the hydrofluoroether, versus this perfluoroketone that Paul was just mentioning and that what 3M developed, the perfluoroketone works better with certain applications like AI and or high performance computing, where there's very fast signals and very very high memory needs, right?
Mhm.
So the deal was that, as we mentioned, the perfluorocarbons had issues with global warming potential. Paul mentioned that 3,000 years and 10,000 GWP. That molecule worked wonderful in two-phase immersion cooling, but the regulatory folks in the world really look at it and say, okay, well, we're replacing air cooling or other liquid cooling, but we're replacing it with a very, high global warming potential liquid. So we started to test the C6 ketone. And what you find is you're giving up the superior stability of a perfluorocarbon, which is totally fluorinated liquid perfluorocarbon, for the more environmentally friendly ketone. So this molecule, the ketone, was developed to be more fragile so that it can break down in the atmosphere, and its global warming potential is 1 or 0. It's very, very small, the lowest global warming potential out there. So that molecule, what we found, and this is, one of the challenges we encountered in developing these safer products, was in immersion cooling for computers and data centers, there were interactions with the stuff that was going into the fluid, where the fluid would break down and then it would break down the hardware. Okay. And this is a very, very pivotal moment for these chemicals, for 3M at the time, and now for Standard Fluids, because we are selling the SF649, is what we call the C6 ketone for immersion cooling. And we are selling that into data center immersion cooling for AI and for, supercomputing or high performance computing. But it needs to be taken care of engineering wise. So certain things have been developed since, the 2016. There was a very bad test that we did with Lawrence Berkeley National Laboratories and Intel and the Naval Warfare Laboratories. And there was a big issue with using the C6 ketone, where it did break down, and it did break down the electronics. But what engineers do is they take a problem and they make a solution. So over the past 6 to 7 years, this application using the C6 ketone has been, really the issues have been solved, is what I need to say, right? Where we put certain engineered systems into these tanks that protect the fluid and really make them the very long lifetime in these tanks, and the lowest global warming potential of fluid out there for two-phase immersion cooling. So
Yeah,
that was,
it sounds like that the key challenge that you guys found was because it's breaking down. Once it breaks down, that's when it starts to cause bad damage to critical things. And like you kind of alluded to, various maybe system providers that utilize this fluid for cooling have ways of maybe circulating or moving it to prolong that breakdown period, so that it
or to
doesn't
stop
happen.
it.
Yeah, or
Yeah,
to stop
stop
it.
the breakdown.
Yeah, to stop it so that it lasts longer, which is really interesting. And it's so fascinating to hear, the way that these products operate is they have a cooling factor, right? That's inherently how all of these work, is they cool things down in various ways. um if
And
you
that's actually how it works in fire protection,
Yeah.
right? Because it cools the fire below its the point at which the combustion occurs. But it does so in fire protection in a very unique ways. While it can break down in the atmosphere very, very quickly in a matter of days or a week, it is very, very stable in the system. And that's the key thing in the fire protection application. It will stay very, very stable there for a long time. In a properly designed fire protection system, it has a shelf life in excess of 30 years. So wow. we've done the accelerated aging studies over the years, and that's so it works very, very well in that application.
Yeah, I would love to. I don't know if I don't think we have time right now, but to hear how an accelerated aging study works, that sounds like a very fascinating process, or maybe not. It could be very, very dull and prolonged. Who knows? But
I was happy when it was done.
Yes, I'm sure. As we know, and Paul and I have had the privilege of going through various testing and stuff like that to see. And the way these tests go, it's they take a long time, and sometimes you have to restart and go again, and it just resets the clock for how long these tests can take. And
that's right.
It's interesting stuff. So, well, it's really good to hear kind of how those developed and kind of hear the background of those things and how they've become safer over time, right? And you guys both kind of talked about that ozone depletion potential, the way it breaks down, or the lifetime, the atmospheric lifetime of these things. What is it about those, we'll kind of touch into how we got here to Standard Fluids, right? And you both talked about, or I know Paul definitely did, Steve can definitely allude to it as well, is you guys both had the option of going down different paths and not necessarily having to come to Standard Fluids, but we're here. We're very eager and excited to be involved in these markets. But what is it on the product side? Obviously, the customer side, we know a lot of people in the industries, and we're really happy to continue working with them. But on the product side, what is it that's so exciting to still be providing these products and still get them out there? And what is it about that messaging or those things that really is exciting to you guys?
Yeah, let me take that on the engineered fluid side. It's really important that, again, baby out with the bathwater, right? So these molecules were developed for their sustainability, and that's really where, Standard Fluids plays this important part, is that the message is the sustainability of the hydrofluoroethers, the C6 ketone, and where it's hitting in certain industries is because of all the regulations that's going on with fluorinated or PFAS materials, right? These fluids have great global warming potential, low atmospheric lifetime, and anything below 270 global warming potential for one molecule, all the way down to 55, and actually 0 for the C6, or 1 for the C6 ketone. So we have the global warming aspect with our fluids is right where it needs to be. It does not bioaccumulate. So I love to tell customers, like, I've been working with this since I was 20 years old, and you will not find a single molecule in my blood of these chemicals. They do not partition to water, which Paul alluded to. Whereas if you have a spill, it will not go into groundwater. It will evaporate up into the atmosphere where it breaks down. So sustainability is the biggest thing. And my passion for these is just, I'm honestly, because it's, not like I'm a one-trick pony, but I've been doing it a long time.
Yeah.
So I have passion for these molecules. And what brought me to Standard Fluids was, Paul Rivers and Lewis, and I met Rory, and really just the team that they started with, former 3Mers, lots of experience and lots of passion on their side. Mm-hmm. So when we all get together, we all know, who we are and the passion that each person has for these products. And then we also have a gentleman by the name of John Owens who works with us on a consulting basis, but he worked for 3M for 40 years, 40 years. And ended up retiring from 3M as well. So he came out of retirement to work with us. So just a lot of passion and a lot of, just a lot of scientific knowledge on these products.
Right. Yeah.
Yeah. So that's it.
Yeah.
Yeah, yeah, Paul, if you want to talk a
Yeah.
little bit, then we'll get into
and when I got involved with this, I mean, it was a thing where we were able to, in a very timely manner, we had to move fairly quickly to be able to assemble the team to be able to do that same brand promise that we had at 3M. We've recreated that at Standard Fluids. We want something to be able to provide that quality, the safety of the products. We have a ISO 9001 certified laboratory that does all of our analytical. So regardless of where it comes from in the world, we do analytical certificates of analysis come from Standard Fluids, and so we know that from multiple sources of supply that the product that we offer into the marketplace is the same brand promise that we had when this team was at 3M, and now it's with Standard Fluids.
Yeah. So I mean, you guys both talked a lot about that history and development. You guys know these products very intimately. Like Steve said, he knows them so well that this is where he thrives. And same with you, Paul. You've been a part of these products for their entire life cycle at this point.
Yeah.
And so you talked about that sort of quality side of things, and that we utilize a 9001 laboratory to do the testing of these things, which is a very critical thing on both sides of the market that we serve. The fire side is really, really important because comes into play with how effective that is. When you need to use this product in a fire application, it's got to work. And that quality aspect is really important. And same with Steve. Steve mentioned how these products break down and how that breakdown can maybe negatively affect it. But if these products are ensured quality that we utilize these testing methods to verify, it's really, really important. So if you guys could both kind of talk a little bit about those and maybe the specific components of the testing that we look for that ensure that quality that we're able to do.
As far as the quality testing for the fire, we go in accordance with NFPA 2001 and ISO 14520 standards, and that's requires that we validate it to for the purity, the acidity, water, non-volatile residues, and also the some other key impurities, the dimers of HFP, the thermokinetic dimers of HFP. And so we qualify that. We have our own methods that we've developed. They're proprietary methods, and that we use that method to make those methods to make sure that whatever is offered into the marketplace is of the highest quality. And to my knowledge, nobody else does what Standard Fluids does there.
Yeah. Same with Steve. Steve, if you want to talk a little bit about the engineered fluids and why we test those, and because I know there's several customers that you've worked with that this testing for quality is very important to their overall success of things. So
yeah, absolutely, and it comes down to the chemistry and the molecule, right? When you want to use a certain molecule, even one small little change in a molecule could mean different things for toxicity or for flammability. So, and we could talk all day about that, but so that's really what it comes down to is Standard Fluids is offering a certain molecule, and the quality behind that is extremely important because of those issues, right? Because of a certain, if it's a cis or a trans isomer or an isomer that was tested and registered or hasn't been registered, and that comes, there's so many issues that could happen in these areas. So we need to make sure that when we test them, we're giving the customer exactly the molecule that we say we're giving them, 99.5 plus purity, and we have the methods for showing that and then delivering the product. So that's the best way to put it.
Yeah. No, and I'll, this is a part where I can kind of lend a perspective of me, the project manager, and I manage a lot of our document organization. And one of the key things is, it's one thing to test these products and show them, but it's another to test every single batch that's produced and be able to supply that certificate to every sale and every order that a customer places with us, so that they know every drop of liquid that we're providing to them is going to meet that, right? It's going to be that product that we are selling, or it's going to meet that quality standard that NFPA, requires. And so it's a cool thing that I know myself and our warehouse fulfillment manager, Jonathan, are excited to do. We're always like to be able to attach that. It really feels like it's a good, solid reminder of what our message is, right? Of that quality that we're trying to ensure we put out in the market and make sure that we're maintaining that. So
one other aspect of that is that you mentioned that each batch is every batch of material that Standard Fluid sells is tested, but we also keep a retains or a sample of that material indefinitely, so that if there's ever an issue down the road for whatever reason, that customer needs to be able to test that material or to confirm material that they had based on that batch that was tested, we can go back to that exact material from that batch and be able to confirm.
And again, I want to add too, because for decades, 3M was making these fluids, and because of their know-how, their knowledge, and the size of the company and the safety measures that were always put in there, there was almost zero issues that we had with quality at 3M with these fluids. So, and as 3M decided to get out of the market and other companies have backfilled in this area, many customers have seen issues with the supply. Many times that's what I would do. So, drums would come in without labels, and drums would, the fluid would smell funny, or this, that, so many other stories that you would hear from the field. And what Standard Fluids is doing is getting back to that quality that 3M was giving. And really, because we're from 3M, we know what we're doing. I mean,
reestablishing that brand promise. That's key to what Standard Fluids is doing.
We're looking into REACH registration for these fluids. So, the ability to sell these into Europe will be very important in the future, and we'll be able to get these REACH registered, and then that'll give us more access to the European market. So.
Yeah, and Paul, if you want to talk about kind of a lot of, you're very actively involved with different committees and organizations on those types of things. You want to talk a little bit?
Right. Yeah. And the important thing for us on the fire side, and actually on the engineered fluid side as well, is and it's a key for us is to have multiple sources of supply. And so we've only been at this a year, as Nolan, you mentioned. So it takes some time to get to reestablish that. We don't want to have single sources of supply to have what's happened with the for lack of a better term, a 3M effect, where they walk away from the market. We have multiple sources of supply of materials, and we want to make sure that that supply is reliable. That's coming from Standard Fluids to our key customers, and while it's also meeting the standards that are required in industry for fire, the ISO standards, the NFPA 2001 standard as well, and that's a key for us. And it's same with the engineered fluid side.
Yeah, there's lots of applications, and there's lots of customers out there looking for it, and we're doing everything to build and ensure that we're able to meet that demand and supply those customers when they need it. It's really hard to find yourself in a conversation talking about our products and talking about what our goals are in the market, and not kind of feeling like the standard in our name is sort of a pun, or it is. We are trying to not only just set the standard, but really kind of maintain that standard that 3M set years ago, right? Like Steve said, every batch, every drop that went out the door at 3M was the best quality, and that's what so many people relied on. And that wavered after 3M left. We are here to ensure that standard is there and even raise it wherever we possibly can. And that's a huge thing. And that kind of, leads into just, our commitment to the future and kind of where things are heading. And I'd love for you guys to just kind of talk a little bit about what's so exciting on the future, maybe allude to, I know we're developing some kind of interesting products that we're excited to do, and new applications for things. Things are developing every single day. Steve talked a little bit about AI and how exciting of a market that is on the horizon, but just talk a little bit about those and show how we're not leaving, right? We're sticking around. We're here for the long run, and we've got a lot of exciting stuff to do. So
yeah, I mean, one item in this discussion, thread is especially in semiconductor. There's a certain molecule that 3M made that is perfect, absolutely perfect for semiconductor, and really gets us past the PFAS issues that we're having, especially in semiconductor, with a global warming potential below 100, boiling point at 128 degrees C. So it really tackles a lot of the applications within semiconductor, and it is stable. So in the systems that it's being used, it's stable. And there have been issues with replacement products where they will break down, and chillers and tools that are multi-million dollars, start to have issues with breakdown of the cooling fluids. So Standard Fluids will be working with that molecule for sure for semiconductor, and also using that molecule in pharmaceutical, healthcare. It really was a standard in those applications for many years.
That's a great point, Steve, because we're not resting on our laurels. We are actually developing new molecules for those critical applications. And one other thing, I happened to watching on one of the business channels yesterday, I think it was, and they were talking about AI, and they're talking about the amount of energy required to run these AI equipment, and all the air conditioning that's required for conventional cooling. And they weren't mentioning anything about the immersion cooling that Standard Fluids is doing, and pioneering that, and putting that forward. That's so this is, we're at the very beginning of this very revolutionary technological change in data generation and computing.
Yeah. No, it's very exciting. Obviously, when I came into this a year ago, I came from a bit of a fire background, so getting to hear a lot more of the engineered fluid side of things and the way things are developing. Steve came in and jumped headfirst into things and got to work, and it seemed like he was working in a market that's been doing this for years and years. And to an extent they have, but not to this capacity, not to this volume. And it's really become clear over the past few months working closely with Steve of like, we are at the beginning of some very rapid growth here. And we certainly got a lot of work to do, but it's enjoyable. It's a fun challenge that we get to do. And definitely something that we all enjoy. It is really kind of fascinating and interesting stuff. And the way it works, and seeing these products actually in their environment working the way that they're supposed to is such a cool thing to see. And it really does, like, explaining it to some of my friends or family and talking to them about these products, it sounds like you're just making things up and it's magic, right? Like the way that some of these work. Paul talked a little bit about how the way that it works in a fire application is it pulls the heat from the fire, and that's basically what stops it. And it's like, how does that happen, right? Because that's not how most people think of how a fire behaves. But seeing it actually work and see how it does that is such a fascinating thing to see. So we'll have to do some more of those kind of technical conversations in the future. But this was a really good kickstart to this. We hope to do some more of these projects and bring in some of the other team members from Standard Fluids to talk about their history, because again, we've got a team with a wealth of experience, a long background in the market, working with 3M, developing these products, developing the market, and getting to know so many of these customers that we're so happy to work with.
Yeah, actually, one of the things about Standard Fluids is that we're available to help with application development.
Yep.
And we have that knowledge that's been there, developed over decades of experience. And if a customer has a new application that they have to to develop a new solution, we can do that. And we can consult on that basis. Not everybody in the marketplace can do that, though. They may be able to sell a product, but they don't necessarily not necessarily able to do what we can do to support our customers.